Hello, this video is under the series of cell in focus. So what we are doing in this series that we came to know what is microscopy, what is the different parts of microscopy, and how the magnifications and resolutions actually we have defined for a microscopy, and that's very important parameters. Now the next important things we have to know that how the image is actually going to be generated. So in light microscopy, as we are dealing now light microscopy, so light microscopy colored image is actually going to be generated. Now how the colored image actually going to be generated means from where the color is coming. So here one answer is that we are using the light from the visible range. We are exciting light from, let's say, yellow light or blue light. So light we are using the visible range. That's why maybe we are getting some color in the image which are in the visible range, and that's why we can see it by our naked eye. That's maybe the one reason, and not maybe, can be the one reason. And another important thing is that from where means whether the whole specimen are going to generate the colored light that is going to be make a image, or some particular point. To answer that, actually we have to say that unlike the tame or SEM, here the whole specimen of your sample is not going to generate any electron or any light type of things. So here the concept comes some biological fluorophore. Fluorophore means, what is fluorophore? Then this question will come. So fluorophore is nothing but a organic molecule, a small organic molecule which is very rich in pi molecule, a pi electron, and there is a pi moiety, long conjugated pi moiety. So what is the characteristics of this fluorophore is that when you are using some light to excite this fluorophore, they will emit some light which is different from the previous one. So the previous one we will call excited light or excitation light, and the latter one we will call emission light. So it will take excitation light and make some interactions in between it and emit some light which will be called as emitted light. That will be excited light and that will be emitted light. And now next thing is next question will come, that how this light is going to be generated, and that is actually different from the previous one. How this differs from the previous one, that will be the next questions. So to answer that, we have to say there is some phenomena is happening. We call it as fluorescence. Okay, it's called fluorescence. So fluorophore is making that incident, that's why it's called fluorescence. So fluorescence is nothing but an incident by which is molecular level phenomena actually, by which a fluorophore is what? Is an organic molecule which contained in which is rich in pi moiety, which takes the light of excitations and emit some other wavelength of light which is different from the previous one. So this two light, the main message we have to know, that two lights, what is going to excite the fluorophore and the light what is going to generate after the interactions which called fluorescence is actually different. So we will know in later that these two light differs in the wavelength. So wavelength of the emitted light, the latter light, emitted light, is actually greater than the previous one. Okay, so now the question we have to come in the point that what is the molecular fluorescence, what is the molecular level explanations of that fluorescence incident. Now to answer that in a very layman word, we have to say we have to take a let's say an example of your home. So let's say you are we are taking an analogy of your apartment with an atom. So you live in an apartment, and there are ground floor, first floor, second floor, third floor. Okay, and this apartment ground floor is the most stable, and as you know, when you are going up, means up in the height, first floor, second floor, third floor, then your energy is increasing as progressively. Yeah, the ground floor is the most stable because that is on ground, and then whenever you are increasing, first floor energy is greater than the ground floor, and then second floor energy is more greater, third floor energy is more greater, like that your energy is increasing. Now let's say you was, so let's say that was the atom. Your whole apartment is actually an atom. And next, let's say you you was in the ground floor, and you actually is a electron. You actually is a electron. You are in the ground floor. And now let's say you have a phone call, and your phone is on the first floor. So you will come to the first. So this phone call you can say as excitation. Phone call you can say as excitation. And the ground floor, that is called the ground state of the electron, ground energy level. And the first floor we will call excited state. Second floor also we will call excited state. Third floor also we will call excited state. So first, second, third, this will be called as the excited state 1, excited state 2, excited state 3, like this. And the ground floor, as in the most stable form, people wants to stay there in the ground floor. That's why we will call it as a stable state, as a ground state. Okay, and another first, second, third floor will be called as excited state. Now what will happen? You have a excitation as the analogy of your phone call. Now you came to the first floor. Okay, now whenever you have came first floor, you can also go to the second floor, you can also go to the third floor or fourth floor. Now whenever you will return back, whenever you are returning back, then if you are in the first floor, if you were in the first, you can directly go downstairs and reach to the stable ground state, means the floor 0, ground floor. But if you are in the second or third floor, okay, if you are in the second or third floor or fourth floor, then you have to come first from the second floor to first one, third floor to first one, or fourth floor to first one. Then you can only come back to the downstairs and go to the ground floor. So this is very important, that you can't directly come down from the fourth to ground. You are not a Spider-Man, isn't? So if you are Spider-Man, you can directly fly to the ground floor, but you are not a Spider-Man. So you have to come from your first or from your second or third floor to the first floor first. Okay, and first floor we call the first excited state. So whatever be the excitation, whenever we are giving some light, some energy, light is energy, light is nothing but energy. Whenever we giving some light, that is energy, then electron means you are exciting. Okay, you are exciting to the first floor. Excitation can anything, to the first floor or second floor or third floor, anything. But whenever you are returning back, you have to first come back to the first floor, and then from first floor you can go to the ground floor by the downstairs. So that is the important thing. Whatever your excited state, whatever be your excited state, that the first floor, second floor, third floor, fourth floor, fifth, anything, whatever be uppercase. Okay, but you have to first come back. You have to first come back to the floor number 1, which is just upon the ground floor. So in electron also the same things happens. Okay, whatever be the excitations, first, whenever no excitation, whenever the normal, your stable state means electron stable state is in the ground state, means no energy. And then whenever you are giving some energy, it takes some energy, the electron takes energy. Now he is excited, he has to go to the first floor, second floor, third floor, whatever be the excitation. But you have to first come back. That's very important. Whatever be the excitation, you have to first come back to the first floor, and then you can come back to the ground floor. So whenever you are coming back from the first floor to ground floor, that is called the de-excitation. So in time of excitation, your initial position was the ground floor, and you are going, let's say, first floor, second floor, third floor. But whenever you're returning back, then your initial position, it can be anything. It can be second floor, it can be third floor, it can be fourth floor. But first you have to come back in the first floor, and this coming back from the fourth floor to third floor means this coming back from the fourth floor to first floor, or let's say third to first, or let's say second to first, that will be called as a relaxation. We called it vibrational relaxation. You don't have to understand, you don't have to go to that deeper. It's called relaxations. Okay, so step one is the excitations, and step 1 can anything, from the excitation from the initial state, that is the ground state, to first excited state, second excited state, third excited state. It can be anything. But whenever you are coming back, that is de-excitation. De-excitation happens in two steps. First is whatever your position is, second, third, fourth, whatever your position is, you have to first come back to the first floor. That is the first step of de-excitation. It's called relaxation. Okay, it's called relaxation. And then you have to come back to the ground floor, and that is called emission. So now one thing is very important, you have to understand that this is the excitation and this is the emissions. Now whatever incident happening from the third floor to first floor, second floor to first floor, that we are not seeing. We are seeing only excited light and emitted light. Excited light, emitted light. You are giving some light, let's say wavelength of yellow light, you are coming back, you are returning back with the excitation, with the light of wavelength, let's say red. Now why this incident happened? You are giving a yellow light, you are getting back a red light. So always the trend is that you are getting the light which is more in wavelength, which is greater in wavelength than the previous one. Okay, so the statement is emission wavelength of emission light is always greater than the excitation light. Why this is? Look, whenever you are exciting, you have given some energy, and that is called the excitation energy. Now in the time of returning back, you have came back to first floor first. So in time of that work, when you are working on that one, third floor to first, second to first, or fourth to first, you have already expanded some of your energy. Okay, some of your energy already have been consumed to make this type of work, second to first, third to first. That's why whenever you are coming back from fast excited state to the ground state, you have quite of less energy as compared to the excitation light, isn't? As compared to the excitation light. That's why the emission light, what you are returning back, this de-excitation, emission light. So in emission light, you have the less energy as compared to the excitation light. And we know energy is inversely proportional to wavelength. Energy proportional to 1 by wavelength, inversely proportional to wavelength. Whenever in emission light you are getting lower energy, then obviously wavelength of your light will be increasing. That's why emission light is more in wavelength as compared to the excitation light, and the same time emission light is less in energy as compared to the excitation energy. And that is actually represented by normal chemistry, by Jablonskii diagram, and that's shown here. This is the ground state. This is the ground state, as I have said, that your ground floor of your home, and you have given some excitation, that is step 1. You have given some excitation, that is step 1. So electron are going to the let's say step 2. So this is the electron are going to the excited state, and let's say this is the excited state 2, this is the excited state 2, and this is the excited state 1. So first you have to come back to the excited state 1, and then you can only come back to the ground state. So this is called excitation. This is called excitation when you are exciting your molecule with a light, with a particular wavelength of light. This is called excitation, and this is called the emissions. And in between what are things happening, that is called relaxation. And what is that incident? That is coming back from second, third, or fourth, whatever, to the first excited state. This is called the emissions. Now whatever I have said, that fluorophore is an organic molecule which have the characteristics to make these things happen. This is called the fluorophore. Now each fluorophore can absorb, means for each fluorophore excitation light, emission light is different, and emission light obviously will be dependent upon the excitation light. Okay, and for all the case, one statement will be correct, that emission light will be greater than the excitation light. For all the case, one thing is obviously true, that excitation light will be lesser in wavelength than the emission light, or in reverse, emission light always will be in greater wavelength as compared to the excitation wavelength. Okay, so that's the thing, and that has been described by the Jablonskii diagram. So you can describe from now that emission wavelength is greater than the excitation wavelength. Thank you. Hope you understood the concept. Thank you for watching.